Okay, we're going to find the domain of a much more complicated looking function. There are two steps to do. Again, I need to make sure that the inside of the square root is positive, and then I have to make sure that I eliminate any numbers that can make a bottom of a fraction 0. But we're going to do the first part first. We need to solve this inequality. We're going to do this the way you did in your college algebra class. I just write down the inside of the square root. And this is, I don't know if you remember this or not, but this is how you do this in a college algebra class. You make a number line, a big long number line. And on the number line, the only numbers that you actually put are any numbers that make the top 0 or make the bottom 0. For example, when I set the top equal to 0, I get x equals 0. So that is a number that's going on my number line. When I set the top equal to 0, I get 3. So that's a number that's going on my number line. When I set the bottom equal to 0, I can get 1. When I set the bottom equal to 0, I can also get -1. So those are the only x values that you actually put on your number line. Now what am I supposed to do with this? Once I get these numbers, I want to plug them back into my function just to see what I get. When I plug 0 back into this, I get 0 on top and -1 on bottom. That's 0, so I'm just going to put a little 0 here. That's actually going to be helpful. When I plug 1 back into my function here, it makes the bottom 0, which means this is not even in the domain, so I'm just going to cross it off. When I plug 3 back in, it makes the top 0. It makes the bottom something like, I don't know, 8, but whatever it is, it's fine. The top is 0, bottom's 8, the whole fraction is 0. I'm good with that. When I plug in -1, it makes the bottom 0 again. That means it's not in the domain, so I'm going to cross it off. And I put a little f of x over here. Now, we're going to make a sign chart. The way we make sign charts is that we've just chopped up the number line into 1, 2, 3, 4, 5 pieces, and all I want to do is pick an x value from each piece, plug it back into the function, and see if I get a negative answer or a positive answer. So for example, I'm going to pick what number over here. How about I pick something like x equals -10? Anything that's to the left of -1 is fine. We try to put test values in boxes. If I put a -10 on top, I get -10 times -13, so I get a positive answer. I get something like -11 times -9, that's also a positive answer. That says when I plug -10 into my function, not my original function, right? I shouldn't do this. Just the thing inside the square root, I get plus. Right here, the only number I can think of that's actually even sort of nice is x equals -1/2. So that's the one I'm going to put in my box. When I put in a -1/2 here and a -1/2 here, I get negative times negative, that's positive. When I put a -1/2 here, I get negative times positive. So I'm going to get positive, positive, negative, positive. I'll multiply all those together, and that's going to make that negative. The only nice number I can think of between 0 and 1 is 1/2. So that is what we're going to put right here in our little box. Remember, it's not on the number line as a test value. Now when I put a 1/2 here and a 1/2 here, it looks to me like I get positive, negative. When I put a 1/2 here and a 1/2 here, I get, I think, negative, positive. So I think that's going to be positive. Negative on top, negative on bottom. So I get something like that. Now a number between 1 and 3, how about 2? Again, put it in a little box so that we know it's a test value. Put a 2 there, put a 2 there, you get negative. Put a 2 there, 2 there, that's 1 times 3, well that's positive. So on the top I get negative, on the bottom I get positive, so the whole fraction winds up being negative. Whew. Right? Now, I now need a number bigger than 3. How about something like 10? You might say, why does it have to be so far away? I just like not having to worry about the arithmetic. If x is 10, that's positive, 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 positive. Yay. Now, what does this do for us? It actually allows us to write down a conclusion without breaking too much of a sweat. The x values that we can plug in the inside of the square root and get positive answers are all the numbers here, and all the numbers here, and all the numbers here. So if I'm talking about domain, I need probably to include all the numbers less than -1, Now, I'm not including -1 because I know when we plug in -1, it makes the bottom 0. They usually put an OR here, which means include these numbers as well. I want all the numbers between 0 and 1. Now, by the way, when I plug in 0, it's perfectly fine. I get a nice answer. When I plug in 1, we cross that off, so I don't include that one. And the other answers can be anything bigger than 3. And when I plug in 3, I get 0, which is perfectly fine. We can take the square root of 0. And we've taken care of everything because we actually crossed off the values that made the bottom 0. So there's our domain. And you can see we had to know an awful lot and be able to do an awful lot. So all that college algebra we had to take before, you now get to use it. Hooray!